Thank you for participating on this webinar. It will be dedicated to thermo-optical modeling of optical components, which is the topic I'm working on at HiLACE for about 8 years already. We will start with a very general scheme of the thermo-optical calculations, how we use it in our group. Then I will say a few words about the energetics calculation, which is like the first part if we are doing the thermo-optical calculation for laser amplifiers. The next part will be already the true thermo-optics, and it will be about heat deposition, which is the part which is for laser amplifiers is taken from energetics calculation, and for passive optical components it's calculated usually from simple absorption of the laser radiation in that component. The next step will be some brief summary of the calculation of heat removal. Then I will talk about the heat transport. It's the calculation which gives us the temperature distribution in the component. Then the thermal stress, which is induced directly by the temperature gradients, and the thermal expansion then leads to the generation of thermal stresses and strains. And all this preparation is made in order to be able to do the true thermo-optical calculation, which is the evaluation of temperature-dependent refractive index, dielectric tensor. Then we are doing the calculation in the combination with another polarization phenomena, like natural birefringence of the crystal, optical activity of the crystal, electromagneto-optical phenomena, and this is all combined with stress-induced birefringence, potentially also with induced deattenuation. So all this is the most important part. It's the thermo-optical part, and from this we can calculate the beam propagation through the thermally loaded component, like the wavefront distortions and polarization distortions. The last part will be something what we call energetics thermal loop. And then I will just briefly mention the validation measurements which could be done to validate the results from the calculation.